Skeletal muscles are the means to manipulate the external environment. What's the point of a reward system if you can move towards pleasure, or a fight or flight response if you can move away from discomfort or pain? So skeletal muscles are ultimately the end for all needs, whether this is from hearing to seeing to locating, capturing, chasing, and even consuming. It all involves movement and contracting of muscles. So without the brain communicating efficiently to the muscles when to contract, when to move, we as well as our dogs would be pretty helpless. And yet the power of this bi-directional communication system is often underestimated. Our dogs are wired to move, and without us providing sufficient activation of muscles and movement, we do see serious health issues. But on the other hand, too high of an arousal sometimes lead to muscle activation that can interfere with our training, that might look to some of us as disobedience, but really is an involuntary behavior of dogs. This and so much more will be a topic of this episode. I'm Dr. Melanie, and today we're going to talk about the neurobiology of movement. I want to start this episode with a story. The story is about Jean-Dominique Bauby. He's French, or was French rather, and I might not be pronouncing his name properly. But in 1995, he got into a car accident. And he got into a car accident because he suffered from a stroke. And as he was gaining consciousness again, he realized he's in a hospital. However, he wasn't able to move at all. Not one muscle was under his control anymore, but he was completely conscious. The only muscle that he had left, that was under his control was his left eyelid. And you can imagine the terror and the discomfort that one might go through if you're fully conscious. You can hear, you can see, you can understand, but you cannot move at all. And yet over the next year, he was able to write a book about his experience with the help of nurses and assistants and his left eyelid blinking. This book is called The Diving Bell and the Butterfly, with the diving bell being the weight, the heavy weight, the sinking heavy weight of his body, and the butterfly being his mind that remained to be free. And I'm telling you this story because I want to highlight how we often underestimate, but also take for granted the ability to move and have our movements under control of our consciousness. And with this episode, I want to bring awareness back to this communication between the brain and the skeletal muscle, and also the beauty of it. So before we dive deeper into the role of muscles in movement and exercise and how this applies to dog training and dog behavior, just want to briefly talk about the structure and the function of muscles themselves. So dogs have on average 300 to 400 muscles. We humans, we have about 600, so twice as many. Probably makes sense. We're bigger and larger than dogs are. And the difference between skeletal muscles and other muscles that we usually call smooth muscles is that they are voluntarily controlled. Meaning, if I want to lift my arm, I can lift my arm. If my dog wants to move from A to B, my dog is under control of moving the limbs. In contrast, smooth muscles are the muscles that line your digestive tract or your cardiac muscles or your lung muscles, so that you still continue to digest. So you still continue your heart beating and your breathing, even without you consciously having to decide doing it. So today we're going to talk about skeletal muscles, mostly because they are under our control. And also in dog training, this is mostly when we're hoping our dogs are under control, right? Each muscle consists of a bundle of muscle fibers. They kind of look like tubes when you look at pictures of how muscles are organized. And each muscle fiber also is arranged into muscle fascicles. And in order to measure strength of a muscle, you would take the cross-sectional area, so the thickness of a muscle. And to judge the speed, that would depend on the length of a muscle. There are also two types of muscles. We have type 1 that specializes in endurance, and then we have type 2 that specializes in power and strength. Now, often we also hear red muscles and white muscles. That would refer to type 1 or type 2. And of course, these muscles don't have actually the color of red or white, but they indicate what they're specialized in and how that actually works. So dogs, for example, mostly have red muscles. And what that means is that these muscles are surrounded by a lot of blood vessels. Surrounded by a lot of blood vessels is good because that means you have a lot of oxygen available. Within the red blood cells, we have this molecule called hemoglobin. You might have heard of it. And oxygen binds to hemoglobin and is then transported throughout the periphery of the entire body. And if a lot of oxygen is available to the muscles, that means that the muscle has a lot of energy. And that speaks to the endurance of muscles. In contrast, cats, for example, have more white muscles. And they are not necessarily specializing in traveling long distances or needing a lot of endurance, but they need really fast and powerful movements. So a cat leaping at the mouse means there has to be a lot of efficient communication between motor neurons that activate muscle contraction. And that movement has to be super fast and super powerful in order to catch the mouse. And because this communication between neurons and the muscles is very efficient and very strong, we talk about white muscles instead of red muscles in cats. Now, when I talk about motor neurons, I talk about neurons that make contact to the muscles in the periphery. Now, the contact here looks very similar like the contact between two neuron cells. They don't necessarily touch, but they communicate through neurotransmitters. One of the main one here is acetylcholine. And these communication areas are specialized areas that we call neuromuscular junction. So at these neuromuscular junctions, you have the muscles that are very close to the motor neurons. They're called motor neurons because they are responsible in activating muscles and therefore making them contract and therefore making the arm lift, the leg move, and whatnot. Now, these motor neurons that go throughout the periphery, they are all located in the spinal cord. But there are other brain regions that are also necessary to create these really elaborate movements, sometimes really complex movements, not just for humans, but also for dogs. So I want to just briefly mention the brain areas that are needed to create all these movements. Again, the spinal cord here is where the so-called lower motor neurons disseminate into the periphery. In the periphery, they communicate with the muscles themselves, but then come back to the spinal cord. In the spinal cord, we have the control systems for reflexive movements. So if you accidentally put your hand on a hot stove and you move your hand back, that's a reflexive movement that is controlled in the spinal cord. The reason for that is we do not want to have extra time needed to travel all the way up to the brain, get processed, communicate back to the spinal cord, and then communicate back out to your hand muscles. It has to happen really, really quickly. And to shortcut that communication, we have the motor neurons coming out of the spinal cord that cause the quick movement directly. The spinal cord is also responsible for rhythmic movements. So walking or trotting or sprinting and even chewing, so anything that is very rhythmic, is also controlled in the spinal cord for the most part. It's called central pattern generator. And these motor neurons that are, again, originated in the spinal cord, they can activate spontaneously to create this kind of rhythmic movement. So for example, in cats, where the brain stem is not connected to the spinal cord anymore, so it had been cut, these cats can still generate walking movements. And that's important so that we don't spend too much energy thinking about how to move first the left leg and then the right leg. The same for dogs or animals. It becomes a very automatic pattern that can be, again, controlled through the spinal cord motor neurons. And then, of course, the spinal cord connects all the neurons to the brain. And that's what we call the corticospinal tract, which means that all the neurons that come from the motor cortex, so the area in the brain, in the cortex that is responsible for generating other movements, goes all the way down through the spinal cord connects with what we call the lower motor neurons there, that then again go out into the periphery and cause the contraction of the muscle. Another important area of the brain that is involved in movement is the cerebellum. The cerebellum is, compared to other areas, pretty small, but it packs a lot of surface area that is organized in a lot of lobes. So it really looks like a sponge. And the cerebellum is important for the timing, the coordination, and the accuracy of movement. You might have heard of cerebellar hypoplasia. It's a disease that some cats suffer from, some dogs suffer from. I had a client or have a client that suffers from cerebellar hypoplasia, and it is very characterized in uncoordinated movement. They kind of wobble from A to B, and they can't really coordinate their limb movement. They fall over easily, and it's because the cerebellum is probably underdeveloped, either due to misdevelopment in the womb, or sometimes also due to viral infections that causes this misalignment in the cerebellum, and therefore a impaired signaling coming from the cerebellum that leads to uncoordinated movements. And then, of course, we have the motor cortex. It was mapped out in 1870, first time by a German neurologist and a German anatomist. And what they did is they took dogs and electrically stimulated parts of the brain, parts of the cortex. And they realized that if they stimulate areas of a very narrow strip that is right on top or across the cortex, they realized that the dog starts to move its limbs. And that's how we know that there's a motor cortex that is responsible for a lot of elaborate and complex movements. Last but not least, we have the basal ganglia. The basal ganglia is interesting because it kind of coordinates the step and go movement. So in order for something to really work out in all of the complexities when we move or when our dogs move, it's not just moving one limb or moving one part of your body, but oftentimes also not moving a different part of the body. And the basal ganglia coordinates the stop and go signals so that we have, in summary, the ability to really generate complex movements. Okay, now that we know how movements are being coordinated by the brain, what areas of the brain are involved, and how muscles are being structured and different types of muscles, I want to now highlight the importance of exercise. This applies to us humans, but in particular, it applies to our dogs as well. And I'm going to start out with a study that has been done in 2016 and 2017 by two researchers. And what they did is they took moderately active adults and kind of forced them to experience a more sedentary lifestyle for a period of time. So these adults, they would exercise on a regular basis, and now they were asked to be more sedentary, meaning sitting longer at their desk, on the couch, and just not move as much. And the results are pretty significant. After only 2 weeks, the majority of them felt more tired, they felt more anxious, and even more hostile to friends, family, and colleagues. 81% of all the participants also reported to feel more depressive. And 31% of all the adults that participated in this study reported a decline of life satisfaction. And in continuation of this study, what they say is if you only take, and I have to look up the number here, 5,649 steps per day, you are much more likely to experience these symptoms that the participants of this study experienced, meaning feeling more anxious, feeling more depressed, feeling more tired, feeling more hostile, meaning less social. Now, Americans, on average, walk 4,774 steps a day. That is below the minimum for the study that says you're starting to see negative impacts on your life. Now, if we don't walk enough, chances are that our dogs don't walk enough either, because our dogs have to work with us. And in fact, in 2022, 1 of 3 dogs showed symptoms of anxiety, whether this is towards other dogs, towards other people, towards new environments. The numbers here are very, very clear. We do not move enough, and our dogs don't move enough either. Now I'm going to switch to wolves here for a moment because I think it is important to see how dogs evolved and potentially what their needs are. Now we know that wolves travel 11 or 10 to 30 miles per day. So they're in movement about 8 hours a day, either to hunt down prey or to also locate and navigate their territory, maybe even expand their territory. Now, of course, you can argue that a domesticated dog is not a wolf. The lifestyle is very, very different. And that is true. The domesticated dog appeared approximately 11,000 to 16,000 years ago. Now, this is a long time for genes to change, for evolution to further take place. And in fact, they probably arose from a now extinct lineage of wolves. But the question is, what do dogs need in terms of their movement? Are they closer to what wolves need, or have we actually created different kind of needs? And the answer here is going to be mixed. Plenty of evidence shows that dogs have been used throughout history for work alongside humans. And if you look at ancient paintings, they really show a picture of dogs being involved in travel, in physical activity. Now, if you look at modern breeds, many of them have retained their physicality, their anatomy to work and to travel over long distances. Now, of course, there are exemptions. Small dog breeds or brachycephalic breeds, meaning short-nosed breeds, they have features that doesn't allow them to travel over long distances or endure stringent physical work. However, most of the breeds still do. And in fact, some breeds like the Huskies show endurance that outlast that of wolves because we have bred them specifically for this kind of work. Now, I mentioned all this process from wolves to domestication to modern dog because now I'm going to give you neurobiological evidence why dogs on average are still made to walk, to trot, to jog, to run with us. You all probably have heard of the runner's high. The runner's high is a phenomenon that you see in long distance runners. It takes a while until it kicks in, but apparently when it kicks in, it makes you feel elated. Runners report that they have no worries in the world anymore. They feel just great. They don't feel any pain anymore. For a very long time, we didn't really know what was going on there. But now we have a much better understanding how, and it all comes back to contracting muscles, how the runner's high leads to the sensations and the feelings that runners report. Some of the molecules that are being released during the runner's high are endocannabinoids. Endocannabinoids are natural molecules, hence endo, that are being produced and released on demand, meaning there are no storages in the body. But precursors, lipid precursors, are being stored in the membrane of specific cells. And as the production is triggered, endocannabinoids are being produced and released, causing lifting mood, no stress, no pain. The sources of endocannabinoids are neurons, of course, immune cells, and of course, muscles. So physical activity is inducing the release of endocannabinoids. Now, you could say this is the runner's high, and this is when humans run over long distances. What about dogs? There's been a researcher, his name is Reichlen, and Reichlen conducted a study where he put dogs on a treadmill, and as a control group, he used ferrets. Why ferrets? Ferrets are nocturnal animals. They don't have to travel long distances to capture their prey. So dogs and ferrets have been put on a treadmill, and after 30 minutes, what Reichlen reported is an increase of endocannabinoids in dogs, but not ferrets. And more importantly, he also controlled by the intensity, meaning just walking, leisurely walking, did not induce endocannabinoids, but running or trotting in that scenario did. Yet this is another evidence that dogs are still wired to move. The activity of trotting or running is a rewarding activity for our dog. And based on evolution, it makes sense because this activity ultimately leads to either finding food or not. It is independent of the outcome. The wolf that continues to travel to secure the territory, to look for prey and finds that rewarding will never stop. If it would be dependent on the outcome of finding prey, of increasing the territory, which it doesn't always happen. In fact, it probably happens less often than it does happen. If that would lead to a reduction of wanting to travel, of wanting to move, we would have an extinction of wolves. So the brain makes sure that these kind of activities that have been important for survival and that our dogs still show the anatomy and physicality for is a rewarding activity by triggering the release of endocannabinoids that just feel joyful and put your dog in a really blissful state of mind. The effect of these runner's high molecules on the resilience to stress is also quite remarkable. In studies with rodents, they show that after running on the treadmill, mice are being less fearful in unknown, normal, uncertain environments. And the more they run, the more receptors they express for endocannabinoids. So that means that the brain becomes more susceptible to all joys, not just running, and more resilient to all stressors. And I believe this to be true for dogs as well that go on long walks 4 to 5 times a week. They become more motivated for work, they become more resilient to stressors, and they become better companions overall, healthier companions as well. Now, you might wonder, how does this happen? How long do I have to walk my dog? When do I know that there will be more endocannabinoids being released? Well, it doesn't necessarily happen overnight, right? Especially if your dog is not used to walking longer or having moderate activities. In certain studies, what they say is it takes about 6 weeks for humans to really increase the expression of endocannabinoids regularly. In studies with rodents, it was 21 days. And after 21 days, the brainstem that coordinates a lot of movement as well as the prefrontal cortex has been altered for the better. And in that case, it was rats that have been used and measured in terms of their brain activity. And again, they became more resilient and braver in many different scenarios, not just right after running. Now, the runner's high is associated with not just endocannabinoids, right? So we know that more than 25 molecules are being released by contracting by activated muscles. The first studies that have analyzed this or found this call them hope molecules because of their positive effect, not just on the physical health, but also on mental well-being. And it is important to say that it is more targeted towards endurance activities rather than really high intensity activities. So here's my first protocol that you can apply to see if you can trigger the release of endocannabinoids in your dog. For 21 days, go on a 20 to 30 minutes walk every day. Now, in terms of the pace, it is important that it's not too slow. So if you can hit about a 10 minutes mile for 20 to 30 minutes, that would be, I think, a good starting point. Now, if you are a little slower than your dog, which happens a lot of times, what you can do is find an area where you can put your dog on a flexi lead so your dog has more room to move around you or in a certain radius faster than you walk. This is, for example, what I do. My dogs tend to walk a lot faster and I can always keep up, but I keep them on a flexi lead, especially if I go on hikes. And therefore, they can walk a little faster. They walk back and forth, left and right around me. And that way, they do have a pace that is inducive for the release of endocannabinoids without me getting super exhausted. Now, another way that you can incorporate this moderate activity is play. This is an entire different topic, but moderate play the right way, meaning the right balance for your dog of elements that are good for cooperation, elements that are good for competition, do release endocannabinoids too. It is a very social interaction that usually includes you being very active as well. Be very careful here with just using fetch. Fetch often triggers a high arousal prey drive that may or may not lead to the release of endocannabinoids. So if you want to incorporate play maybe right before walk, so you don't have to go 20 to 30 minutes, or you can potentially go a little bit slower, make sure that you really play a social game that incorporates elements of cooperation and competition. That's for you to set up a protocol, a strategy to induce endocannabinoids through walks or moderate activities. But what if you do something with your dog where you have really high arousal? Now, here I want to switch to the discussion of adrenaline for a little bit. Adrenaline is the main driver for increased muscle activation and contraction. Adrenaline makes the muscle want to move. Any kind of situation that induces the stress response, that induces excitement, activates the sympathetic nervous system. And the sympathetic nervous system activates the release of adrenaline. And I mentioned earlier, adrenaline does make the heart pump faster. And adrenaline also makes sure that a lot of oxygen reaches the muscles. So if the muscles scream, move. Now, this becomes a problem in certain situations where we want our dogs to remain calm or come back to calmness, even though there is a stress response that has been activated, even though they are hyper excited, even though everything inside them screams move, because adrenaline is being released, because muscles are being provided with a ton of oxygen, and the heart is pumping to get it to them. And you can probably imagine what kind of situations I'm talking about here. There could be reactivity, a dog getting a little bit too aroused by the sight of other dogs, whether this is out of excitement generally or out of fear. Oftentimes, we want our dogs then to remain calm. So we scoop to the side, we say sit, we say look at me, we say leave it. If this is accompanied by the requirement of our dogs being stationary, being still, be very, very careful here. You might add a lot of conflict because, again, all the muscles, the entire body screams move. Another example is you coming back home and your dog being incredibly excited to see you, or maybe being incredibly excited to see visitors come in. They're jumping, they're lunging, they're doing zoomies, they're barking. Now saying sit and leave it might not work. And if you have gone through the frustration of trying it, there has to be a different outlet for your dog because, again, everything says move. The muscles, the brain, they're communicating, and the brain is telling your dog to move. So you will have to align whatever you do in your training with that internal signal. And then, of course, there are certain dog breeds that are easily aroused, and we leverage that for certain type of training in sports, for example. Now, that high arousal can also become problematic. So let's look really quickly here what's happening. If there's really high arousal, meaning incredible activation of maybe the stress response or just the brain saying we need to be ready here, the motor neurons that communicate with the muscles, if they fire at a very high frequency, we see a so-called tetanic contraction. So what does tetanic contraction mean? It just means a sustained activation and contraction of the muscle. You might have heard of tetanus, the neurotoxin that also leads to a sustained contraction of certain muscle groups. So high arousal, high activity can also lead to a tetanic contraction, meaning these muscles just start to contracting in a sustained way. They cannot relax anymore. Fire at a slightly lower frequency, what you then see is twitching of the muscle. So twitching is activating the muscle very quickly, but the muscle relaxes for a very, very short period in between. So that leads to twitching. And now if you further increase the frequency of these motor neurons firing, meaning activating the muscle, you see the tetanic contraction where the muscle is being under tension the entire time. Now imagine a dog that is in anticipation of you throwing the ball, or a sport dog that is in anticipation of starting the agility course or biting the decoy on the field or you getting the tag toy out. You can feel the tension or see the tension in your dog's body. So the anticipation, again, activates the sympathetic nervous system. Adrenaline shoots through the body and ultimately leads to an activation of the muscles. And the contracting muscles, either sustained or sometimes you see the twitching of the hind legs, for example, prepares the body for bigger movement. And it's important because a muscle in motion or body in motion, even if it's just twitching, can switch to bigger motions much more efficiently and faster. Even we as humans do that. If you watch tennis players, they jump from the left to the right because that will allow them to be much quicker when they actually have to catch the ball in one or the other corner. If you now start to ask your dog to do certain things that doesn't align with the muscle tension or the activation, it can become a problem. For example, a dog switching positions from a stand to a sit. This is something that my friend Mike Ellis talks a lot about. where you have a sort of like slow down motion to a sit because the muscle tension does not allow the dog to go into a sit faster. The only way to go then into a sit and not hover over the ground is by lowering the arousal level. So it takes a moment, the arousal level lowers a little bit. The muscles can now relax because the motor neurons don't fire as frequent anymore. That's when the entire sit position can be achieved. Forcing a dog to go into a sit position faster, however, will activate the stress response that will cause the motor neurons to fire more frequently. And now the dog is even less likely to go into the sit position. So we have to be careful here what we ask our dogs, given their arousal level and given their anatomy and physicality and what they're able to. This also applies sometimes to releasing a toy if the dog is really, really aroused and excited about it. So for a dog that bites and doesn't let go easily, it might be because of disobedience, but it also might be because the activation of the muscle, the sustained muscle contraction, makes it harder for the dog to actually release. Let's take this one level deeper. Again, why is it so difficult to make a dog that is biting down on a toy or, God forbid, another dog or human being to let go? Well, the jaw muscles are getting signals from the so-called periaqueductal gray, PAG. The PAG area is also activated during stress response, during a fight or flight response, during hyperarousal. So firing of these neurons that come from the periaqueductal gray can lead to a sustained muscle contraction. Now, two things will happen here. The jaw muscles potentially get stronger and bite down stronger, but also won't let go or relax easily because of the high frequency that these motor neurons fire signals saying this muscle has to be activated. And what then happens is that the dog has a very hard time to relax these jaw muscles and let go of the toy or whatever the dog is clamping and biting down on. This brings me to the end of this episode. I hope you enjoyed learning more about what your dog needs are, the urge and willingness to move, to run, to walk, to be active. Learn to move with your dog so that you can also enjoy downtime on the couch together. I'm Dr. Melanie, and I'll see you in the next one.